Welcome to 3.1 Electrons and Lewis dot diagrams. This lesson is going to be really short because there's not really much to talk about this until we talk about molecular structure and other stuff like that. So basically we're going to be talking about Lewis dot diagrams, and all atoms have an outer shell of electrons that can normally interact with other atoms through chemical bonds. Right? We're going to learn through most of these chemical bonds throughout the chapter, and we're also going to learn something about electronegativity, which will be pretty cool. So the outer shell of electrons is depicted by something called a Lewis dot diagram. So we have a bunch of protons, a bunch of electrons. That's what keeps the atom. That's what makes the atom the atom. So, for example, lithium has one. This lithium right here has one electron. You can see that by our previous chapter, we have the 1, 2. We have the 1 plus, 2 plus, 3 plus, 4 minus, 3 minus, 2 minus, and 1 minus pattern. Right? This is basically exactly that pattern, but instead of the 3 minus, 2 minus, 1 minus, we have 5, 6, 7, and then the 0 is 8. Right? And I'll explain to you why 0 is 8 in probably the next lesson or this lesson. Depends on what the slides tell me, right? So the outer shell of electrons is depicted by a Lewis dot diagram. So it looks like this. It's the atom and then one electron, because lithium has one electron in its outer shell, right? Each dot represents an electron on two subshells. They're called the S shell and the P shell, right? You can find the S shells right here, and you can find the P shells right here. And every atom right here has the same S shell as this, right? That's why all of these are mostly 2, because they mostly have 2 s electrons, right? We're going to talk about S and P more later. You probably don't know what S and P is. You probably think that I'm talking trash. It's just quantum orbitals, basically. But it's also known as a valence electron, which means electron on the outside. So lithium has one valence electron, and O2, this oxygen molecule, shares electrons through two bonds, and this is called a covalent bond. If you've learned chemistry before, it's called a covalent bond, and this is how you depict it. We'll be learning all of that in probably next lesson, right? So this, we have to make sure that we know how many. Actually, yeah, we're gonna learn about the 8 electron rule this time. So, for example, we want to draw the Lewis dot diagram for phosphorus. Where's phosphorus? Right here. We have 1, 2, 3, 4, 5. Germanium is Ge, I think. Where is germanium? Stellar chlorine. Germanium, right there. Right, that's 4. So Ge, 1, 2, 3, 4. And cesium is 1, because it is an alkaline metal. I know that. Cesium, Se. Ce, I mean Ce. Right there. So, no, CS, I mean CS, I'm sorry, CS. So that's it. And the next one is atoms can lose or gain electrons to become monatomic ions or polyatomic ions. We'll talk about those later. Maybe in this chapter, maybe never. This will change their Lewis dot structure. For example, O2 minus has 8 valence electrons because 6 of them, 6 valence, are from the atom, and 6 valence electrons are from the atom, and 2 of them are given to them, right, from the charge. Atoms like to be closer to 0 electrons as possible. So when they have 4 or less, they choose to be 0. They have 0 electrons, and when they have 4 or more, they choose to have 8 electrons. There's a gray line between at 4 electrons, so carbon and silicon, for example, can form different compounds. For example, SiO2 has 4. It forms a silicon cation because silicon dioxide is there's a 2 minus charge for oxygen, which means 4 minus total. So silicon has to be 4 plus, right? But in other cases, carbon, I think, no, in other cases they can be negative. So the reason why they have 8 or 0 valence electrons, when I say 0 valence electrons, I don't actually mean 0. They just have 8 valence electrons, but on their next shell, right? So it might not be on their next S and P shell. We'll talk about that later. Actually, I might talk about that now. So we have an atom right here, right? Let's say, well, we have quantum orbital. Oh my god, I'm sorry about that drawing. Okay, so we have a nucleus, right? And then we have an atom, and let's say 1, 2, and then another shell, and that's 1, 2, 3, 4, 5, 6, 7, 8, right? And then another shell, but this only has 1 in it. So if this atom gives away this electron's removed. So the outer shell has 0 electrons. I'm going to denote this with red. The outer shell has 0 electrons, but it doesn't actually have 0 because the next shell next into it has 8 electrons, has the whole 8 electrons. That's why it's called the octet rule. Oct stands for 8. So lithium, let's draw the following ions. I said draw. Oh, I'm so stupid. Actually, we're not going to draw anything. We're just going to name the symbol, right? So lithium plus. Most of the ions form 8 or 0, so we don't actually have to draw anything, because lithium plus is just helium, right? Lithium plus is just this. We could draw 2 around it because they have 2 in the last layer, but really, lithium's just that. Nitrogen loses 3, so nitrogen will have all 8. Bromine will, boron has nothing because it gains 3 electrons. No, it loses 3 electrons and gains 3 charge. Bromine, well, bromine is an anion, so it has the full 8, right? Anions have the full 8 and cations don't have any, but they have 8 on the next shell. You have to remember that. So octet rule, which of the following should not exist? B, beryllium 2-, yes, exists. Sulfur 2-, does not exist because it has to gain 2 electrons to get the whole. Actually, wait, I confused myself with my own notation. Beryllium should not exist because it has to gain 2 electrons to become stable. Silicon exists. Iodine does not exist because it has to lose an electron, not gain an electron, right? It has. Yeah, iodine does not exist because it has to gain an electron, not lose an electron. I mean, this stuff might be a little bit confusing to you. Ask me a question if it is confusing. AS3-, because I'm even confusing myself. AS3- is because it gives away 3 it gets 3 electrons. AAT is yeah, it is because actinide is it gains 1 electron. Iron 2+, that does exist because remember we talked about it last time. And then H+. H+ has absolutely 0 electrons. H+ has 0 electrons. But an atom can have 0 electrons, and that's what makes the water in your thing more acidic, is with the 0 electrons. So the transfer of the electrons can be modeled by the Lewis dot structure as well, right? They normally occur during chemical reactions. So for example, SiO2, silicon, oxygen, I modeled it right there, right? So Ca and Cl2 is calcium, which has, I'll just draw the 2 chlorine first. They have 7 each. So 1, 2, 3, 4, 5, 6, 7, right? And then calcium has 2. So calcium 1 goes there, and calcium 2 goes there. I'm sorry about. I'm really sorry about the unpreparedness. Okay, so a way to know how many electrons they have, how many electrons an atom has, just based on its charge, is if it's a cation, that's the amount of electrons it has. If it's an anion, take 8 and perform the operation. So, for example, oxygen is an anion, normally forms anions, right? With 2- charge. So take 8 and perform the operation. 8 minus 2. 8 plus 2-, which is 6. So oxygen has 6 electrons, right? Iron 2 and oxygen, well, iron 3 and oxygen, so this is a 2- charge, and this is a 3+ charge because iron 3. So we need 2 of these ions, and then we need 3 of these. So since it's a 3 plus charge, we know to draw 3 ions, right? Fe, Fe. No, since it's a 3 plus charge, we know how to draw 2 ions, and then O, O, and O, right? So we have 1, 2, 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. Right, we can put this there, we can put this second one there, we can put this third one there, we can put this fourth one there, we can put this fifth one there, and we can put this sixth one right there. And that's really messy as well, but and that's really messy, but I can draw it at the end if you want. If you feel confused, just ask me in the comments, right? That's what the comments are for. That's gonna be it for today's episode. This is a pretty short episode, and next time we'll be learning about ionic and covalent bonds and electronegativity and all that. So see you next time.